Sairam everyone. So have you thought about it? Memorization skill? Started practicing it, recall? It's very important. We will go for the content here. I think we were solving the problems, right? So we'll start with the problems again. And in the second part of it, we will go for refraction at the plane surface. So we'll just, how many? I think 2 or 3 problems are solved. Now actually it is very important for all of us that you should be able to read the problem, understand the problem and get the solution of it. And yesterday it was observed that you were having some difficulty in getting the solution. But with the practice, you should be able to get it easily. Okay. So we will start now. I'll give you a problem. And as soon as that problem, you are able to solve it. If somebody is coming to the board and explaining, it's better. If he misses some point, I'll be there to explain you. Okay. A thin rod of length f/3 is placed along the principal axis of a concave mirror of focal length f such that its image which is real and elongated just touches the rod. What is the magnification? Concave mirror of focal length f such that its image which is real and elongated just touches the rod. What is the magnification? Now every problem is going to be new for you. You should be able to understand the question and draw the figure accordingly. And then you should be thinking of the other aspects that has been asked to you. So it takes some time. Please draw the figure first, then we will try to analyze it. And there you will come to know that drawing a figure is extremely important. So how many of you are able to draw the figure? Okay, now do one thing, start reading the problem loudly, any one of you, so that I can show how the figures are to be approached. Anyone who can read the problem loudly? So you are given the rod of length f/3, right? So you are having here the rod of length that has been given to you as f/3. You are given a concave mirror, am I right? Concave mirror. So obviously the focal length will be taken as negative for that. F is the focal length, it will be negative. Now read the image part. So you are having the image real. Image real ka matlab hota hai the value of m will be negative. Then yes, it is an elongated image, matlab it is an enlarged image. Please read that part. How is that rod placed? Along the axis. So you should understand this very clearly that if I am considering here a concave mirror in this manner, if I am considering here a concave mirror with this line as a principal axis and the pole present here, principal axis and the pole that is shown here, then you will be having this point as a focus, then this point will be center of curvature. So how is the rod? Along the axis. So are you going to show the rod vertically perpendicular to the principal axis or along the axis? So how are you going to place it? Horizontally, but how it should be? The image, one end of the image must coincide with one end of the rod. इसका ये मतलब होता है that you will be having the rod whose value is f by 3. This distance is f. This distance will be taken as focal length f, right? So obviously the distance from here to here will also be f. बराबर है? Right? Now you have to see that the rod of size f by 3. So this is f by 2. Somewhere here, this is the position of the rod. This is the position of the rod that you will be able to have. Yes? 2. What you have calculated? देखो, I have m is equal to minus, correct? But actually you are using a formula for magnification. You are using a formula for magnification for a vertical rod. You have not considered the magnification formula for the horizontal rod. That is why we are going wrong. What you are trying to do, you are trying to use a formula which was taught to you earlier. In a hurry, you are trying to get the answer. It is not working for you. Am I right or wrong? So condition have changed. You have to think about it. Now, in this particular case, where will be the image formed? This is the first important thing. How the image will be formed? Image will be inverted. So there will be two ends of it. One end is present somewhere here. This is representing the distance which we are able to call it as u1. And from here, the distance to this end will be taken as u2. Am I right or not? So can I work with this particular formula here? 1 upon v1 plus 1 upon u1 is equal to 1 upon f1. Sorry, f, because focal length is not going to have that value. It's going to remain the same. Right? Now, can you tell me what will be the distance of center of curvature? Can I put it down it as u1 is equal to minus twice f? So I can put down this relation as u1 is equal to minus of twice f. Sorry, no, u1 is minus 2f, no, 2f minus of f by 3. 2f minus of f by 3, okay? Now is it okay? And the distance up for u2 would be taken as minus of twice f. So can I calculate the value? 1 upon v1 plus, you are having 1 upon u1, so it is 1 upon minus of twice f. Twice f is the total distance minus of f by 3 is equal to 1 upon minus f. Because focal length of the concave mirror will be taken as negative. Am I right? Can you solve this to get the value of v1? Can you solve this part? So 1 upon v1 will be equal to 1 upon twice f minus of f by 3 is minus of 1 upon f. So I can put down this as 6f minus of f, that is 5f by 3. So 3 upon 5f minus of 5 upon 5f. So you will be having the answer as minus of 2 upon 5f. So value of v1 will be taken as minus of 5f by 2. Can I take this value? Can I take this value for v1? Everyone has got it? Now calculate for the second part of it. So in second part, you will be having here 1 upon v2 plus 1 upon u2 is equal to 1 upon f. So 1 upon v2 plus 1 upon u2 is taken as minus of twice f is equal to minus of 1 upon f. So you will be having 1 upon Vf, V2 will be equal to 1 upon twice F minus of 1 upon F. Multiply this by 2, divide this by 2. So you will be having 1 minus of 2 minus of 1 upon twice F. So value of V2 will be equal to minus of twice F. Do you agree to this answer? So image and the rod are in contact with one another. Are the image and rod in contact with one another? That is described in the problem, right? Now you can find out what is V2 minus V1. So if I go for modulus of V2, because I want to only find out the separation distance, so it will be taken as twice F is greater, 5F by 2 is greater. So 5F by 2 minus of 2F, how much it will be? 5 by 2 is F by 2 will be the answer here. And the object distance that is taken as how much? F by 3. F by 3 object distance. आपको दिया है प्रॉब्लम में that the rod is of length F by 3. So what is the object height? Size of the object कितना आएगा? F by 3 आएगा, right? And size of image ही दिया हुआ है. So can I find out this particular relation that magnification here will be taken as minus of delta V upon delta U. So you will be having minus of delta V. How much is that? F by 2 divided by F by 3. So it is F by 2 divided by F by 3. So your answer would be taken as minus of 3 by 2. Left side. This step. It's a minus sign for the measurement of the distance that I have shown you. But what is that point? ये distance कितना रहेगा? P से ये वाला distance कितना रहेगा? ये 2F यहाँ तक है? अरे ये point तक कैसे 2F रहेगा? 2F will be up to C. Minus 2F minus F by 3 तो आप left में चले जाओगे ना और you will be moving to the left more. Now, what I want to find out, forget about the signs. Sign पूरी तरह से भूल जाओ. आप मुझे सिर्फ इतना बताओ that how much is this distance? 2F minus F by 3. And minus sign is attached only to show that we are measuring the distance from pole to that end. That is why it is there like that. Okay? Write down a problem. A plane mirror is placed 22.5 centimeter. A plane mirror is placed 22.5 centimeter in front of a concave mirror of focal length 10 centimeter. Find where an object can be placed Should I start repeating from the beginning? Find where an object can be placed between the two mirrors, so that the first image in both the mirrors coincide. First image in both the mirrors coincide. repeating the problem here. A plane mirror is placed 22.5 centimeter in front of a concave mirror of focal length 10 centimeter. Find where an object can be placed between the two mirrors so that the first image in both the mirrors coincide. Sure. Draw. Okay. So you are given a concave mirror. You are having a principal axis shown. You are having the pole marked here. Right? What is the distance between the concave mirror and a plane mirror? So, is the focal length of the concave mirror given? So, focal length of the concave mirror is given to you as minus of 10 centimeter. Am I right? So, if I consider this as the focal length, then you will be able to have this distance as minus 10 centimeter. And you are having here the plane mirror at 22.5 centimeters. So minus 20 would be this position. This is center of curvature. So this distance would be taken as minus of 20 centimeter. And you are having at a 2.5 centimeter away from center of curvature the position of plane mirror. How is the plane mirror placed there? In front of a concave, means you will be taking here the plane mirror at this position somewhere. This distance from pole to this particular plane mirror is going to be minus of 22.5 centimeter. How many of you are able to put down the picture up to this mark? Okay. Minus 18.5. I don't have the answer here as minus 18.5. Okay, I'll try to understand it. Now, what is the question first? Where you should place the object so that both the images will coincide. Now, image produced by the plane mirror will be virtual as well as erect, right? So, if I want to place the object somewhere in between at this point, suppose I am putting the object here, and I call this distance from here to here as equal to x, because object distance will be always taken from the pole. So, I will be able to talk about this distance. That will be taken as 22.5 minus of x. Am I right? Now, if you are having the object present at 22.5 minus of x, where will be the image produced? Image will be produced at the same distance, so it will be shown here, somewhere here. This distance from here to here will also be 22.5 minus of x. Able to get it? Now we want to make sure that our image lies at this particular point only. So there should be an image that is produced by concave mirror. This is the image produced by the plane mirror. So what will be the image distance? What will be the image distance? Kitna aega? So actually, if you look at it, it's all to be added up. So image distance V will be equal to minus of inner bracket 22.5 minus of x plus 22.5 minus of x Am I right? Plus x, that will be the image distance. So it will turn out to be equal to how much? Minus of inner bracket 45 minus of x. This is the final image distance. Am I right? So can you use the formula for the concave mirror that 1 upon V plus 1 upon U is equal to 1 upon F. So I will be having here 1 upon, the value of V will be taken as minus of 45 minus x plus 1 upon minus of x is equal to 1 upon focal length, that is given to me as minus 10. Okay. So you will be able to get this as 1 upon 45 minus x plus 1 by x is equal to 1 by 10. So you will be having x plus 45 minus of x divided by 45 minus of x multiplied by x is equal to 1 by 10. Factor x is getting cancelled here. So you will be having 450 is equal to 45x minus of x square. So you are getting a quadratic equation, x square minus of 45x plus 450 is equal to 0. Now you can have that formula directly use. X is equal to minus of b. Minus of b यानी plus 45 हो जाएगा, plus minus under root of 45 square minus b whole square. 45 square will be 2025. 2025 minus of 4ac. So it is 4. A is 1 multiplied by c. So value of c is 450. So 450, 2s are 900, 2s are 1800 divided by 2 will be here. So you will be having here plus 45 plus minus, you are having under root of 2025 minus of 1800. So 225 will be there. 225. So you will be having here 45 plus minus 15 divided by 2. So 45 plus 15 will be 60. Either the answer for the x will be 60 plus 60 by 2, that is 30 centimeter, or you will be having the answer as 45 minus 15, 30 by 2, x is equal to 15 centimeter. Now out of the two, which answer you would consider it to be correct? Why? Correct. So answer will be 15 centimeter. Yes, it will be magnified because it is between C and F. Very true. But actually magnification related nothing is given in the problem. That is why I was not interested in magnification. I was only interested in the position. Okay. So how much would have been the answer? If you are considering that image is at 22.5 minus x, no? हाँ तो कितना आएगा? वही आएगा ना, 45 minus x ही आएगा ना? X is not known, we have to calculate x. If you consider x is equal to 30, where will be the object? It will be beyond the mirror. So beyond the mirror, it will not produce the image. So it should be between the mirror and the concave mirror, then only it will produce the image. All of you are getting the solution here. Copying the solution is not important. You should understand the method by which we are proceeding ahead. Done? Have you done the problem? Did you get how I calculated 2025? Did you get how do I calculated this particular value? 2025. कैसे? Are you aware of that? No? That all shortcuts should be known to you. Okay, write down a problem now. An object is placed in front of a convex mirror at a distance of 50 centimeter. At a distance of 50 centimeter. A plane mirror is introduced. Covering the lower half of the convex mirror. Covering the lower half of the convex mirror. If the distance between the object and the plane mirror is 30 centimeter, it is found that there is no parallax. It is found that there is no parallax between the images formed by the two mirrors. What is the radius of curvature of the convex mirror? What is the radius of curvature of the convex mirror? Read the problem effectively, draw the picture, draw the ray diagram, and then decide. The images produced by both convex mirror and plane mirror exactly coincide with one another. We say that there is no parallax. Okay? Good. Anyone else who has got the answer? How many of you have drawn the figure? Figure not drawn? So then get the answer there.
So as we know that object distance is 50 centimeter and the distance between mirror and the object is 30 centimeters. So between these two it will be 20 centimeter. Of course image distance will be after 30 centimeters. So here it is 20 means total 30 is here 30 10 we will get. 20 minus 30 minus 20 is 10. So we got image as 10 centimeters. So we got to know V is equals to 10 centimeter. By the formula 1 by V plus 1 by U is equals to 1 by F. Here as V we should take, this is convex mirror, so we should take image distance as plus. So 1 by 10. Image distance we should take minus because this is that side. Minus 50 by 1 by F plus minus 50 plus 10 divided by T into 10. So if we solve this, we will get F is equals to 25 by 2. So as we know that C is equals to 2F. Therefore C is equals to 20.
Only always remember we are measuring the distances from poles, so put down negative sign.
Okay.
That's fine. It's okay. Good. Very good. So everyone has got this? How many of you have got the correct answer? Raise the hand now. क्या हो गया? So what you have learned from this example, only you have to consider the distances properly. If you are able to consider the distances properly, you will get the answers correctly. Right? Right or not? Formulas are going to remain the same. Only how you are applying is extremely important. Always we should stick to the convention that the light will be traveling from left to right. And whenever you are measuring the distances, you should consider the direction of light. If you are measuring the distance in the direction of light, then you will take the distance as positive. If you are measuring the distance in the direction opposite to that of the direction of light, then the distances will be taken as negative. Able to get this?